Alright guys, just going to make a quick video to go over these. I know some of these we went over in class, but that way tomorrow, Tuesday, we can just get right on to the review and get on with it. So, again, we did some of these in class, but in case you missed them or just want to see them again, real quick. The angle of elevation from a ship to the top of a lighthouse on the shore is 18 degrees. So the ship is right here. Here's the lighthouse. It's 40 meters. And how far is the ship to the shore? So pretty easy setup. Remember, angle of elevation goes above the line of sight, so that's your line of sight on the ground. We have opposite, hypotenuse, adjacent. The pen. Opposite and adjacent are the two sides that are giving you information. So we have tangent, and the tangent of 18 equals the opposite 40 over the adjacent x. Well, let me go back there. So 2 steps, times x, that cancels. X times tangent 18 equals 40. Step 2 divided by tangent of 18. So, in your calculator, you're going to do 18 divided by tangent 40. And that should give you... sorry, hold on. 40 divided by tangent... I think I said that wrong. 40 divided by tangent of 18, which is 123.107. And that's in meters. Okay? So we did that one together. 13. Mike is flying a kite. He has let out 300 feet of string. The string makes a 64-degree angle with the level ground. How high is the kite? So we've seen this setup before on a few tests and quizzes. So the 300 goes here, 64 here. How high is the kite? So opposite, adjacent, hypotenuse. Nope, not adjacent. Hypotenuse and opposite have information. So opposite and adjacent, opposite and hypotenuse is sine. So sine 64 equals opposite x over hypotenuse 300. One step here, 300 to both sides. You get 300 times sine 64, and 300 times sine 64 gives you, man, this pen, it's not the pen, it's the screen, honestly, at this point. Let me try that again. So it should give you 269.638, and that's feet. Okay. All right, number 14, a salvage ship sonar locates wreckage at an angle of depression, 12 degrees. A diver is lowered 45 meters to the ocean floor. How far does the diver need to go? So, excuse me, sorry about that. So, we're going to start, let me size this up a bit. So we can't see the whole problem, but we should have more space to write. So here's a ship. There's the wreckage, right? So the 12 degrees is done right here because this is the line of sight here. And then that's the direct line to the wreckage. So it tells you that they dropped the diver down 45 meters. And they want to know how far across to the wreckage, and that makes a right triangle. But again, with these angle of depression problems, you'll see here that the 12 degrees is not actually in the triangle that we generally solve on the ground. So again, there's two ways to kind of approach this. You can understand that this makes a rectangle, so that's 45 over here. You want that the length across the ground, so x on top as well, and you can just solve from the 12, which from here would give you opposite, hypotenuse, adjacent, right? And so the 45 length and the adjacent variable is what we're going to solve for. So let me zoom out a bit. So that's going to give us tangent 12 degrees equals opposite 45 over adjacent x. Two steps. Times x times x. X times tangent 12 equals 45. And then you're going to divide by tangent 12. And you're going to do 45. There's just certain spots on this screen when I'm writing that it doesn't want to write for me. So 45 divided by tangent 12. That is going to give you 211.708. And that's meters again. Okay? So I know this video is a little bit rough. I'm just having trouble with the iPad and the pen, but it's fine. The mascot holds the end of a kite string. This is number 15. 4 feet above the ground. The string makes an angle of elevation of 38 degrees. If 55 feet of string are let out, how high off the ground is the kite? So assuming you're going to be able to see what I see, and I have a lot of space down here at the bottom, what I'm going to do is this. I'm going to split this in half. I'm going to do 15 right there, and then I'll do 16 over there in a minute so I give myself more space. Even though I had remade this worksheet to give me space, and yet here we are. So this problem, much like 13, sets up like this. It's 55 feet of string, 38 degree angle of elevation. How high is the kite? But the added piece here is that there is a mascot holding the edge of the string 4 feet above the ground. So when we solve this triangle, we are not going to get the height from the kite up here to the ground. It's going to be from the kite to this point, and then we're going to have to add that 4 to the end. Okay? So this gives us opposite, hypotenuse, adjacent. Opposite and hypotenuse is going to be sine. So sine 38 equals opposite x over hypotenuse 55 times 55 to both sides, and 55 times sine 38 is 33.861. Okay, so that's the length from the kite to the line of sight. And then, I should probably go back and erase that little line there. Then you have to add the 4 feet from the mascot's hand to the ground. So 4 there, and you get 37.861, and we're talking about feet. Okay? All right, 16, a person in an apartment building sights the top and bottom of an office building 400 feet away. The angle of elevation to the top of the building is 35. The elevation to the angle of depression to the bottom is 38. So you have this. This is okay. I think I'm going to have to redraw that a bit. Give myself some more room on it. Okay. So okay, so you have 400 feet between the buildings. The person on this has, I'm going to put the angle right there, is 35 degrees. That's the angle that goes right there. Man, just some places this pen does not want to write. And right here you have 58. So what you do is you've created 2 right triangles. Okay? And so just solving it simply, we're going to solve that, and we'll call that x. Then we're going to solve that, we're going to call that y. So right there is the split between the 2 right triangles. You got to find both parts. So on the top triangle with the angle of elevation, you have opposite, hypotenuse, and the 400 is the adjacent. So opposite and hypotenuse for the top triangle, you have sine 35 degrees equals opposite x, and I'm totally wrong there. Let's try that again. Opposite and adjacent is tangent 35 equals opposite x over adjacent 400. This is 400 times tangent 35, which is 280.083. I'll add that in a second. And then on the bottom triangle, you have opposite, hypotenuse, and that 400 is still adjacent. So it's the same setup. It's tangent 58. This time our opposites y are adjacent, still 400. You're going to get 400 times tangent 58, and 400 times tangent 58 is 640. 134 basically. So we got to add those two values together. 280.083 plus 640 plus 134. And that's going to give us a number if my calculator decides to work. And it doesn't. 640.134 4 is 920.217. Okay. All right, so on to problem 17, which on... All right, so 17. I have some space above. I'm going to write it up there. Your cat is trapped on a tree branch 6.5 meters above the ground. You have a ladder that is only 6.7 meters long. If you place a ladder on the tip of the branch, what angle will your ladder make with the ground? So one of the few problems where we have inverse trig, so that's opposite, that's hypotenuse, that's adjacent. Wow. I don't know what to tell you sometimes, guys. This pen and this iPad has just gotten worse as the year goes along. It's really weird. But you have opposite, you have hypotenuse. So that's sine x equals 6.5 over 6.7, the hypotenuse. Inverse trig, so you're going to do sine with the -1, 6.5 over 6.7. And if you put that in your calculator, that should give you 75.96. Jeez Louise. 75.965 degrees. And there you go. Number 18, an observer in a lighthouse 80 meters above the surface of the water measures an angle of depression of 12 degrees to the distant ship. How far is the ship? All right, so 80 meters, angle of depression of 12 degrees to the ship. How far is the ship from the lighthouse? So again, like that problem earlier, we encounter the problem of when we set this up, our angle of depression is in this right triangle above, and the information is in the bottom. So again, we can just put 80 there, x on top, opposite, adjacent, hypotenuse. That's opposite and adjacent. And they're very similar numbers to the problem earlier. So it's going to be tan 12 equals 80. Come on, dude. Over x. 2 steps times x to both sides. That cancels. You get x times tangent of 12 equals 80. Divide by 12. Tangent 12. And you get 80 divided by tangent 12. And the ship is 300. Oh, 370. That's the number if it'll let me write it. And that's in meters. Life. Just kidding. A wire from the top of the building to the ground makes a 19.7 degree angle with the side of the building. The wire is 200 feet long. So This problem was actually on your quiz. And notice that it doesn't say angle of depression. I do actually want you to pay attention to that. This one does say with the side of the building. So on the quiz, we gave you the picture to use, but basically, you have your building, there's 200 feet of wire, and the 19.7 is right there. They want to know how tall is the building. So not an angle of depression. This actually does put the 19.7 there. So we have hype, adjacent. That's not adjacent. See, I'm so used to writing it down there. I'm totally wrong. The 19.7 is up top. So that's opposite. X is adjacent. We're going to use hypotenuse and that's going to be, let's see, cosine of 19.7 equals adjacent x over 200 hypotenuse. Let's scroll down a bit. Times 200 times 200 and you get 200 times cosine 19.7 and 200 times cosine 19.7 is 188.294. And that is feet. All right, almost done. 20, a loading platform is 1.15 meters above the ground. Someone asked me about this earlier, and it's not meant to be one of those mascot above the ground things. That's kind of a bad drawing. It is supposed to be just a regular, like, ramp, right triangle, made from a ramp. So it's just that. That didn't make it any better. 1.15 meters above the ground. How long must a ramp be in order to make an angle of 20 degrees? So the 20 degrees right there, they want to know that. So opposite, hypotenuse, adjacent. You see opposite and hypotenuse. So sine 20 equals 1.15 over x. 2 steps times x, and then divide by sine 20. I'm just going to jump to that because this is not working very well with me. And x equals 1.15 divided by sine 20, which is, the ramp has to be 3. Where'd it go? 3.362 meters. And the last one, from the top of a tree 15 meters high, on the shore of a pond, the angle of depression to the point. Okay, so remember, you got to have that line of sight, and so the 67 goes up here in this corner. How far is the other point? So come straight down. What is the width of the pond? So again, remember, they want to know this So we can put that up there and there. Ah, not there. That's wrong. You can put the 15 here. From 67, 15 is opposite. This is adjacent. That's your hypotenuse. And you have tangent again, much like all those other problems with that. So tangent 67 equals opposite over adjacent. 2 steps. I'm going to shortcut this one because you should know the way this works out by now. X is going to equal 15 over the tangent of 67, and 15 divided by the tangent 67 equals 6.367. Is that right? Yeah, because 67 will be yeah, that should be right. So 6.367 meters across. All right, so there really that many problems. It should have gone pretty quick. You can look back through the answers for those. Hope that helps. Good luck. See you tomorrow.